Greetings, this is John Graves, a student in the Deep Reinforcement Learning Nano degree at Udacity in July of 2018. I've just been collaborating with my classmates Wendell, Huck, and Henry on a discussion of a Judea-Pearl paper, The 7 Tools of Causal Inference. My tuition for the Udacity is paid for by my employer, Curious. I'm using their slide template to present this paper. I'm based in Auckland, New Zealand. Henry's there in Canada. Huck is, I believe, in Georgia. And we're going to be introducing this Deep Reinforcement Learning Nano degree, the paper and our observations about it in just a few minutes. The Deep Reinforcement Learning Nano degree is running its first cohort here in 2018. You can find out more in the udacity.com website, Nanodegree 893. We've just covered the first part of the course at this stage, the introduction to deep reinforcement learning, and discussing papers like this one in the Hash Research channel on the Udacity Slack. We are putting the schedule for upcoming talks of this kind onto a Google sheet at this bit.ly link, DRLND talk. And while we're talking about sheets, we also have a resources sheet called DRLND links at bit.ly, which includes references to a number of other resources, articles, blogs, how to use cloud services, other parts of the Udacity and deep reinforcement learning community competitions, GitHub repositories, papers, tools, and videos. So don't miss out on that resource, and please contribute to it if you can. So let's talk now about Judea-Pearl's paper, The 7 Tools of Causal Inference. This is a draft paper available from the UCLA server, where Judea-Pearl is a professor of computer science. He evidently intended the paper to appear in the July 2018 issue of Communications of the Association of Computing Machinery, ACM. Pearl himself is a winner of the Turing Award for his work on Bayesian networks and his continuing work at age, he'll be 82 in September, on causal inference. He's also recently the author with Dana McKenzie of a book, The Book of Why, The New Science of Cause and Effect, which I found a very interesting read, and you can find out more about it on his website, linked here at the bottom. These slides will also be made available in the Udacity Research Slack channel. Observations about this paper, again, it was intended to be in this July's ACM communications, which, kind of the headline or the cover image is making machine learning robust. The cover image very cleverly toggles between this picture of a lamb and a picture of a wolf, if you happen to visit the website. And a number of other articles, including this one by Ian Goodfellow as a lead author, refer to reinforcement learning in various ways. The President's column, Vint Cerf, mentions the success of reinforcement learning and its contribution to AlphaGo 0. And Judea-Pearl himself continues to iterate on his views about the importance of causality for the development of a strong AI, indicating as recently as July 11th that learning machines need the guidance of a model of reality, as he calls it. This is echoed by a recent keynote speech by Jan LeCun of Facebook, where he says, AI systems are weak in inference, common sense, and cognition because they lack a world model. We are suspecting that these great minds think alike, and this is the current sort of bleeding edge of AI development at this point. So the paper itself puts forth a list of nominally 7 tools, but perhaps there really are only a couple of them that are tools. These ideas of D-separation and the do calculus. If you haven't read the paper yet, the basic concept of D-separation is that it provides this fundamental connection between causes and probabilities, telling us for any given pattern of paths in a model what pattern of dependencies we should expect to find in the data. While the do calculus allows for models where a backdoor criterion doesn't hold, a symbolic engine to predict the effect of policy interventions whenever feasible. So the whole paper proposes a 3-tiered model of seeing, doing, and then counterfactual kinds of questions that these tools can operate under, and implementations that include graphical representations and equations. There are a number of additional references to these concepts if you would like to go further into them. And the Book of Why is also an excellent read.